Okay, let us see a problem of hetero-associative. If we want to train the given neural network with hetero-associative memory, what we should remember, whatever the input is there, output it is different. So where we are applying mostly in problems of clustering, so inputs and outputs are different here. We are just trying to use some of the properties, and connected with that properties we will get the output. So there are two set of inputs are given to us. This is the first set of input whose output it is this one, and this is the second set of input whose output is this one. If your question is train the neural network for hetero associative memory, hetero input and outputs are different, and test it for same input, or test for some of the missing values, test for some of the wrong values, see how we can find out the answer. Let me complete my question. If we are training, so for training we need to find out the required weight matrix, and then for testing I am taking a question. There are two set of inputs, so just assume in the first set of input, if I am considering second missing value, I am considering here second missing value in the first set of input. So in first set of input I am considering second missing value. So let us try to solve the problem. Here either you can use Hebbian rule, or one more shortcut we can use. We are finding the weight matrix. So there are two set of inputs. We will find out W1, W2, and then we will go to find out the final weight matrix. So W1 it is equals to, actually you are taking product of inputs and output. So let me consider Xi and Ti. So Xi it is nothing but this your input. So what is size of this? See, if you consider this, one row is there and four columns. Okay, and what about this? Size of this it is equals to one row is there and two columns. We want to take the product, so obviously we cannot take product of such a matrix. So let us change it, 4 by 1 and then 1 into 2. So how we can write down? Xi transpose into Ti. So let me write down Xi transpose. So instead of row, let me consider it as a matrix, 1 minus 1, 1 and minus 1 into product. Target it is minus 1 and minus 1. Okay, so let us find out the product. First row into first column. See, what is the size? Total 4 rows are there, 1 column. And what is size of this? Size of this is there, 1 row into 2 column. So what will be the final size? 4 by 2. 4 by 2 means total 4 rows will be there and 2 columns will be there. Okay? So first row, first column, minus 1. First row, second column, minus 1. Minus 1, minus 1. So this is 1 and 1. 1 into minus 1 and 1 into minus 1. Then minus 1 into minus 1, so plus 1. Minus 1 into minus 1, it is equals to plus 1. So 4 by 2. See the size. In similar way, we will find out the second matrix, W2. Again, transpose of second input. So it is minus 1, 1, 1 and 1. And 2, target 1, it is 1 and 1. Let us find out the product. So product it is equals to first row into first column, minus 1. First row into second column, so it is minus 1. I am having little bit issue with the writing pad, so I hope you can understand. 1 into 1, 1. So it is 1, 1. 1 into 1, 1. So 1, 1. 1 into 1, 1. So 1, 1. This is the second matrix. Let me here itself calculate the value for W. What is W? This is equals to W1 plus W2. So if I am taking addition of, this is the matrix weight matrix W1, this is weight matrix W2. If I am taking addition of this two, it will be minus 1 minus 1. So it is equals to minus 2, minus 1 minus 1, it is equals to minus 2. 1 into 1, 2, 1 into 1, 2, minus 1 plus 1, minus 1 plus 1, so this is 0, 0, then 1, 1, so this is 2 and 2. So this is my weight matrix. Try to understand the question. Your question is, train the given neural network with the heteroassociative memory. So training, it means updating the weights. So this is the updated weights. So you trained the neural network. So here you completed first part of the question. Now let us see testing. We want to test it. Where we are testing? We are having two observations. So in the first observation, if second value it is missing. Second value means this one. If some value it is missing, let me consider the input xi, this is our input. So it is equals to, first one it is, let me see again, 1 minus 1, 1 and minus 1. 1 minus 1, 1 and minus 1. Okay. What we need to test, if second value it is missing, whether it gives me the same output, because we train the neural network. So what output I am going to consider? If value it is missing, this value it will be replaced by 0. If value it is wrong, the same value it will be replaced by minus 1. Just imagine if fourth value it is wrong, then it will be replaced by plus 1, minus of minus 1. If third value it is missing, it will be replaced by 0. If first value it is wrong, then it will be replaced by minus 1. Okay, missing value replaced by 0, wrong value replaced by minus 1. So this is the input. Now input it is change. If I am testing, so whether I will get the same output, that we need to check. So what is the process? Let me show you. Just like our neural network, we are finding net input, that is weighted sum. We are finding xi into w. Which w we are using? This trained weight matrix we are using. Again, don't get confused in size for multiplication. What is size of xi? One row is there, 4 columns are there. And what is size of this weight matrix? 4 rows are there and 2 columns are there. So as it is, we can take the multiplication. Okay. So let me consider 1, 0, 1 and minus 1 into weight matrix is, weight matrix is, first row is minus 2, minus 2. I hope you can understand. I am having little bit problem with this writing pad. 2, 2, 0, 0, 2 and 2. Let us take the product. I hope everyone remember what is the matrix multiplication. Even if you are having difficulties, easily see what we are doing exactly. 1 row, 4 columns, and here 4 rows, 2 columns. 4 4 get cancelled, 1 into 2. So total 1 row will be there and 2 columns will be there. So first row into first column. I will repeat, first row into first column. 1 into minus 2. It is minus 2. This is 0. This is 0. And this is equals to minus 2. So what is the output? Minus 4. Okay. Then this row into this column gives me the second column. So 1 into minus 2, minus 2. This is 0. This is 0. And minus 1, minus 2. So this is also minus 4. So net input or weighted sum, it is calculated. So what is z? Z is equals to minus 4 minus 4. Now we are going to find out the target value. That is, let me consider target value, that is T1, T2 we are finding. Generally we are seeing this as our output. So how I will find out this? Phi of z. Why we are finding our final output, which is in terms of T1, T2, phi of z. So what phi of z we are applying? Phi of z is equals to it is equals to 1. In bipolar only we are finding if z is greater than 1, and it is equals to minus 1 if z is less than or equals to 0. So phi of z, it will be minus 4. Minus 4 means less than 0. So what output I will get? Minus 1. Again minus 4. So what output I will get? Minus 1. So see, what is the output? Minus 1, minus 1. Now let me summarize. We are testing the neural network. If one of the value it is missing, whether it is able to give me the same output. See this? This was the input where we consider this is the missing value, but still our output it is minus 1, minus 1. So what is our conclusion? Yes, the given network is able to retrieve the same output even though one of the value it is missing. In same way, if it is given that first two values are missing, you are applying the same neural network, only here the input instead of this 1 0, this is 0 0 1 minus 1. If two values are wrong, first two values, so this will be minus 1 plus 1. Okay, so accordingly you can solve the problem. Hetero-associative as compared to auto-associative, there is only one difference. You need to calculate actually more than one input if given. Then for each input you can find out that corresponding weight matrices. Then final weight matrix, it is addition of all the weight matrices. Okay, by finding this final weight matrix, you are completing the first solution, that is training of neural network. And after this, testing whatever the given testing, according to that you are changing the input, you are finding net input, that is weighted matrix, then applying the activation function and observing what output you are getting. Is it same as in the given data? If yes, you can conclude your network is able to retrieve the same results.